All right. So what do we do to solve this? We do what? Using your head. More specifically, what did we do with our heads? Yeah, we can subtract this 7. Absolutely valid strategy here. That'll give us 3x equals -2. Then what do? Divide by 3. Because what are we trying to get when we solve? X all by itself. We want to know what x equals. So when we're trying to solve, we're trying to get our variable by itself. We want to know what x equals. That's what we're trying to do when we're solving. So if our instructions ever say solve, it means find what x equals. So we're going to do that with some of the other ones on this page, like this. So I want to see if we can figure out how to solve this guy. This should be number 2 on that page. There are a few different ways we can go about when we're solving, especially when things have squares in it. But I want you to give this a try. See what you can do. See what we can remember. Because I know you've seen them before. It's just been a while. So see what we can do with it. Stepping that from bouncing around on us. What can we do with this one? Yeah, we can do this in a very similar way that we did the last one. I can add 5 here. That's going to give me that my 3x squared equals our 5 plus 7. We're on number 2. Yeah. So what do we do next? Divide by 3. And we get that our x squared equals 12 divided by 3, which is 4. And then we can do the square root on both sides. So this technique is called solving with square roots. When we do the square root on both sides, what do we get for x? So we know the square root of 4 is going to be 2, but there's 2 options for it. We could have our positive 2 or our negative 2. A lot of times we'll write it like this. Anytime we do square roots on both sides of an equation, we're going to put plus or minus. This is not the only option we have when we have problems like this. We could do this with factoring. We could do any number of situations for it, but whenever we have a square root and we put it on both sides, we have to include this plus or minus. It is super duper important because with our quadratics, when we're thinking about roots, more often than not, we have 2 of them, a negative and a positive. So whether or not that's equal on our axis or somewhere over here, or maybe they're both negative, more often than not, we have 2 roots. So make sure we account for that. So anytime we square root both sides, we need a plus or minus. So same thing for number 3. See what we can do. See if we can figure out how to solve this guy. This one's going to be a little bit different. See what we can do with this one. So what am I thinking for something like this? Because I know with us being quite this quiet, we're either stuck or we're done. Those are our pretty much only options when it's this quiet in here. What are thoughts on we have on this one? Can we do this the same way that we did the last one? Not really. We could try and factor it, because this looks like a quadratic, so let's see if we can factor this thing. That's when we use our x in our box. What goes at the top of our x? A times c. So that would be our 1 and our minus 9, so we'd have a minus 9 up here. And our b is a 42. Is there a pair of numbers that's going to multiply to make negative 9 and add to make 42? Think of the things that multiply to make 9. Things that I know that multiply to make 9 would be 1 and 9 and 3 and 3. Do either of those have a sum of 42? So does this factor? No, it was such a good thought. What other method could we use? You could write it like that. It's not going to be particularly helpful in this place. It's not wrong. You could write it like that. Yes, dear. You could do the quadratic formula. That is definitely one option. That's honestly probably the easiest option. Quadratic formula. Your other option would be you could find our vertex to put it in vertex form. That will let you solve it with square roots. But our quadratic formula is probably going to be the easier option. I do have it set, so we will give you our quadratic formula on the test. You're welcome. So it'll be included in all the formulas. I'll give you standard form, factored form, vertex form. I won't tell you the names, but I'll give them there. I have the axis of symmetry formula up there. And I'll give you the quadratic formula. So all of those are going to be at the top of the test. All 5. They won't have names. You got to know how to use them, but they'll all be there for whenever we need them. So we can set this up, and when we're doing our quadratic formula, it is very, very, very much a plug and chug situation. So I'm going to swap this one out for the pink so that I can have my A, my B, and my C. Because we're going to do our opposite of B, which is green, 42, plus or minus the square root of our B squared, 42 squared, minus 4 times our A, which is 1, times our C, which is that minus 9. Don't lose track of that sign. All over 2 times our A, which was the 1. So it looks a lot like that, and then it's a mess. When we're simplifying it, I highly recommend we do this bit first. This piece is called the discriminant. You probably heard about that in algebra too. There we go. So we're going to do the under the radical part first. Bless you. So that'll give us our x equals negative 42 plus or minus the square root of. What do we get when we put in our 42 squared minus? I say just do the under the radical part. Don't include the radical. In fact, I'm going to change my highlighter here so it's a little bit smaller. Boop. We're going to do just this guy. When we do just that part, our 42 squared minus 4 times 1 times negative 9, we get 1,800. And this is over 2 times 1, which is 2. So if 1800 came out as a really nice, pretty number, that would be super handy. Or if square root of 1800 came out as a pretty number. But the square root of 1800 does not come out as a nice, pretty number. It is decimally and gross. So to get our answers, we need to split it. Even if it wasn't decimally and gross, we would need to split it. So we need to figure out what x equals our negative 42 plus the square root of 1800 is over 2. And we're going to figure out what x equals negative 42 minus our square root of 1800 is. So when we have that plus or minus, we need to split it into our 2 possible options. At that point, we're going to say, oh, my yellow calculator, my very bestest friend, help. Because our oh so awesome yellow calculators can help us with this and do it. But it's really not good at doing it when it's in the plus or minus form. So we need to make sure we have it already simplified and split so that we can do it in a calculator. So to do it in the calculator, I'm going to grab the calculator. Boop. Snap, there it is. So we're going to take and we're going to put in our fraction that has our negative 42. And we can put in our plus. To get the square root, we hit the green button top left. And then we hit the square button. That gives us our square root. And we can type in our 1800 over 2. And it spits out our decimal. So this fractiony grossness, this is our exact answer, or radical form. And this guy, our 0.2132 blah, 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 is our approximate decimal. So our x is just about equal to, and I have forgotten it since I flipped pages, 0.213. I'm just going to have 3 decimal places. 0.213. That gives us one of our approximate answers. Our other root over here, same vibe. It's just instead of adding my square root, we're going to subtract it. So in our calculator, we're going to, again, do our fraction with our minus 42. But this time we are going to subtract our square root of 1800 over 2. It's almost identical. Only thing is we're subtracting instead of adding. So here we have negative 42.213. Okay, so the quadratic formula stuff is a little bit messy. But we can use that. And the benefit of the quadratic formula is that it works every single time. It's just messy. If you would like to be able to solve this without having to do the quadratic formula, our other option is to put this into vertex form, where if I find my axis of symmetry and we find our vertex, we can solve it using the square roots like we had before. So you can do this in our vertex form. It's not particularly pleasant, but it's not awful. It's just longer because we have to put it in vertex form. So the quadratic formula works every single time. Sometimes we can do things with factoring. Sometimes we're just going to straight up solve stuff with square roots. So what I want you to do is I want you to look at number 4. See what we can do for number 4. What kind of solutions are we going to do for number 4? our two solutions here. Just because I don't have it up here. 3x squared plus our 15x minus 6 equals 0. What's that? What's up?
So can we always do the quadratic formula, even if it's
Mhm.
this?
Yep. Yeah, you can always use your quadratic formula. I'll put it up here if you want it. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. So if you want it, there's our quadratic formula. I've got it up here. You are welcome. What do we think about this one? What are we getting? Y'all are silent. So. Mm-hmm.
1 and 15 and 3 and 5.
So is it going to factor? So what other choices do we have?
To do this.
Mm-hmm. We could do that thing. Yep. Yeah. Yeah, this one is not seeming to factor for us. So this is another one that's a great candidate for quadratic formula. You set it up beautifully, but something's got different answers. Divided by 2a. So don't forget that bit. So it's not over 2, it's over 6. It's 2 times the 3. Okay?
Yeah.
Your setup's gorgeous. That's the only piece you've forgotten. So I was going, why is your number different? It looks perfect. Yep. Don't forget that a in the denominator. So again, this sets up 100% the exact same way. So we can set this up with our x equals and our a, which is the 3, our b, which is the 15, and our c, which is that minus 6. So we're going to have our opposite of the b, which is 15, plus or minus our square root of 15 squared minus 4 times our a, which is the 3, times the c, which is the minus 6, over 2 times a, 3. Again, I highly recommend you should simplify this bit first. It's going to make things a whole lot easier to type in the calculator and be able to be reliable with stuff. Because we have our negative 15 plus or minus our square root of, what do we get? Yep, we get 297. So to get our simplified answer and to get our decimals, we need to split it. We'll do our minus 15 plus the square root of 297 over 6. And we'll do our negative 15 minus that square root of 297 over 6. The calculator will simplify it for you. So it's going to give you an in-between step that looks weird, and it's going to have like a square root of 33 in it, seemingly randomly. It's just simplifying and trying to give it as simplified as possible. To get our calculator to switch and give you the decimal, because we need to be able to get both the decimal and our simplified radical form. And those that are not participating today are not going to know this. We hit this button. There is a button just above the enter key that looks like 2 arrows. Because if I type in on here my minus 15 plus that square root of 297 divided by 6, it's going to give us this. And no matter how many times I hit enter, it's going to give me that. But if I would like to have my decimal form, I hit the little 2 arrows and it'll switch it. It'll even put it back. If I say, oh wait, I wanted it as a fraction, it'll put it back. It'll switch it and it'll put it back. So those little 2 arrows are how we get from our simplified radical form to our decimal approximation. So we have lots of options when it comes to solving. We can do factoring stuff. We can do quadratic formula stuff. We can use our square roots. We have lots of options when it comes to solving stuff. What do these equations have in common? Like, look at 3 and 4 in particular. What do we notice about those 2 equations that they have in common that's important when we're solving? What do those 2 equations, 3 and 4, have that's the same? This one, and this one. They're both set equal to 0. So whenever we're solving, if we are trying to do our quadratic formula, it has to be equal to 0. If we are trying to factor, it has to be equal to 0. If we are using our square roots, it doesn't have to, because we're square rooting both sides. But if we're using anything else, we have got to have it set equal to 0. So super duper important. Okay. I know you guys are zombies today, like super duper zombies. Holy cow. I want you to look at the next page, 92. I know, I'm horrifyingly cruel, making us mad. Oh, I weep. I want you to see what we think about this, okay? And you guys can do this like as a group. You can work with your neighbors. You can do this as a collective. We don't care. Think and use our brains, please. So we give you the equation of a bird from Angry Birds. And there's information about a few pigs. And I want to know Are they gonna get hit or not? If I launch a bird on that path. So look at it. See what we think. See what we think. Yes, today is the 19th. We have a week and a half until spring break starts. So your brains can't be on spring break yet. We also have a chapter test between now and then. Or this stuff. And there's probably going to be some solving on there. Just saying. Just saying, just saying. So see what we think about this. At least it's, not just pure equations on this one, it's Angry Birds. See what we think. Can these pigs get hit? See what we think. See what we know. Because there's a couple on here that it's going to be real easy to tell. A lion. Give him a shot. See what we can come up with. Think about it. Put him back there. Let's see.
I don't know if she's still going. I don't know if she's still going. Huh? What is she doing? Nothing.
Should be seeing which of these pigs are going to be hit. Oh, fine.
Nothing. I don't even follow her about her TV. Sure.
Yes, dear. Just 1 second. There we go.
Size.
What's that?
Like, she probably got like a Lowe's.
What does that tell me when it comes to this? So we just straight up solve that and find our quadratic formula.
I don't know if she's still got. She go there.
What chart is it talking about? Vertex. The roots, so that's this guy and this guy. So,
I said her body.
what we're wanting to know is it gonna hit those pigs at those heights? Does this tell us?
Like,
if
you
it's
see
gonna
what I
hit?
mean, type?
No.
Kind, yeah.
What would we need to do to know if it's gonna hit somebody at a height of 45? Substitute it in for what? Is that our time? 45 your time?
She gave you that?
Thank you.
Like
So, the question then is that 45 the time? Because T is the time. So what would 45 go in? Because I agree with you with substitution. I'm switching things around. 16 squared.
I don't know, I just didn't know it's no. I never see the function.
If they hit, they see it, they know.
So we need to figure out when it's gonna be at the height of 45.
You probably never.
Where would we put X 45 in? So we wanna know when that equals 45. Use that, see if we can get it equal to 0, because that's the final answer.
Okay. I have this in the wrong place and I am gonna trip and die.
What are you gonna say? What do I feel? You don't know me, I didn't talk to you.
What do we notice about this?
I'm reading you silly.
Look at our equation up here, guys. What is our y-intercept on our equation? The y-intercept on this one's gonna be 45. So is this going to hit a pig that's at a height of 45? Because what we have here, guys, is that this is our y-intercept, which means this is at 45. Which means I can absolutely hit a pig that's at height 45. The way we would do that algebraically is we would take our 45 and substitute it in for that height. Our 45 plus 25t minus 16t squared. I could solve that. We could set that equal to 0. We could factor. We could find solutions. We could find roots. We could figure out when, figuring out that x value, it got to that height. We could figure that out. How would we be able to figure out if we would get to 57 or 65? How could we do that? We could substitute these in for h and try and factor that way, or try and get to a quadratic formula answer. Or find our vertex. Because our vertex is going to be our absolute highest that it goes. Its peak, its maximum. So that's when we would use this guy, our minus b over 2a. That gives us the x value of our vertex. Or in this case, the t value of our vertex, because they've got them all labeled as t's. So what is the a on this thing? It's not the 45. What is our a? Careful. The minus 16. Because normally our standard form looks like this. Our ax squared plus bx plus c. But because they have these in a different order, I have to find my x, my squared piece. That minus 16 is the a, which means my b is this 25. So we could find our vertex that way. We could take and we could find the x value of our vertex is going to happen when we have our opposite of b, so the opposite of 25, over 2 times a, 2 times negative 16. It's not going to be pleasant, but it's going to be a thing. 25 over 2 times 16. It's gonna give us a fraction that's exactly the fraction we have, 25 over 32, which is unpleasant. But to figure out our height at that vertex, I could substitute it in here. Which I'll do it for us real quick. Which we get our vertex would have a y value, I'm just giving it to you here. Our y value of 54.7. So is there any chance if this occurs at 0.78 and this occurs at 54.7, is there any chance in the world of hitting a pig at a height of 57? Because that's above my vertex. Same thing with 65. It's higher than my maximum goes. It doesn't reach. So the only one we're going to be able to hit on this angle is that 45. We're going to keep working with solving stuff tomorrow. So bring your brains with you because we kind of left them at home today. We were kind of zombies today. Okay? So we have a chapter test next week. I will have chapter reviews for you for sure Friday. We'll see maybe tomorrow. Depends on when I can get to the copy machine.